So let's actually see an example of longest common subsequence. Actually, let's do it with pen and paper, right? So let's do it with pen and paper so that we have a deeper understanding of it with an example. Okay, we learned all the theory, we learned the recursive equation, we learned the optimal substructure, all of that we have learned, but let's do it with hand. Okay, let's actually do it manually. Okay, so imagine if I have two strings, let's call them S1 and S2. S1 is Q, P, Q, R, R. S2 is P, Q, P, R, Q, R, P. Okay, now I want to compute the longest common subsequence between S1 and S2. Let us just recall the recursive equation here. LCS of m comma n, if I have two strings, one of length m, other of length n, is equal to, this is the recursive equation, right? It is the LCS, or the longest common subsequence of strings m minus 1 and n minus 1 plus 1, if the last two characters match. If basically, what does match here mean? Match here means if S1 of n is equal to S1 of m is equal to S2 of n. Okay, if the last character of S1 and the last character of S2 match, then the longest common subsequence. Okay, I'm getting confused with this. I'll just call it LCS. Okay, I'm getting confused with LCM, right, in math. Anyway, so the longest common subsequence with strings of size m and n is the longest common subsequence with strings m minus 1 and n minus 1 plus 1. There is this plus 1 that we need to write, right? If there is a match, or else it is the max between the longest common subsequence with m and n minus 1 and m minus 1 and n. We have seen this recursive equation, right? So let's actually draw the table, right? This is the table in which I'll store my LCS, right? My longest common subsequence, I'll actually store this information here. Okay, let's actually compute the bottom up. Let's actually perform the bottom up dynamic programming manually. And in dynamic programming, as we already know, we store the intermediate results, right? We store, because of the overlapping subproblem, we store the results here. So this is the table. This is the actual table that I will actually use to store this information. So let me just explain you how this table is. So my string S1, which is Q, P, Q, R, R, I've drawn here Q, P, Q, R, R. Okay, I've drawn one more additional column and one more additional row here. So your Q, P, P, R, R has length of 5. 1, 2, 3, 4 and 5. Okay, so this is there on this side of the table. On this side of the table, I have my string S2, right? P, Q, P, R, Q, R, P, and this is of length 7, as you can see here. So what I've done here is I've added one row and one column initially with all zeros. Okay, now let's assume I want to fill this. Okay, I want to fill this. What is this? If you think about it, this is LCS of 1, 1, right? Because I want to find the longest common subsequence between this string, which is only one character long and one character long here. So what we store here in the table, what we store here is LCS of I, j. That's what we'll store in any ith row and jth column. Okay, now to compute this, what do I need? LCS of 1, 1. Okay, let's actually write this down, right? So if you follow the recursive equation here, what is LCS of 1, 1? Is the last character the same? Look at this. First thing you have to check is S1 1 same as S2 1, right? Is it same? P and Q, they're not the same, right? Since they do not match, which means no match. It is not equal to this. Since it is not equal to this, I need to pick the LCS of m, which is 1, and n minus 1, which is 0, and LCS of 0, 1. Between these two, I need to pick a max, right? So you can think of this as 0 and 0. Okay, so of course, when you have LCS of 1, 0, right, if the string length itself is 0, there is nothing to be found. So the value here, because P and Q are not matching, the value here is the max of this and this. Okay, so let me just erase that because I'll use the circles for something else. It is a max of this and this, because what is this? This is 0, 1. This is 1, 0. Right? The max of these two. The max of these two is equal to 0. Okay, now let's go here. Okay, what am I computing now? I'm computing LCS of 2, 1. Right? Because I have 2. Look at this. What does this mean? Here, what am I doing here? I'm taking two strings. I'm taking two characters from S1 and I'm taking one character from S2. right? So what is this equal to now? Now look at this. This P and this P match. Because this P and this P match, what should it be? So again, let's write that, right? So what is LCS of, okay, what is this? What are we computing? LCS of 2, 1. What should this be equal to? If S1 of 2 is same as S2 of 1, right? If that's the case, then we have a match. Look at this. S1 2 is P, S2 1 is P. So there is a match. If there is a match, what should we do? We should take LCS of, right? Subtract 1 from both of them. Right? Subtract 1 from both of them. 1, 0 and add 1 to it. Right? So what is 1, 0? This is 1 and this is 0. This place. So whatever you have here, you add 1 to this. Okay, just also let's circle this to indicate that we have a match here. That's why I'm circling it. Right? Now if I compare this with this, okay, Q and P do not match. Right? Q and P do not match, right? Since they do not match, what should I do? I should just take the max between these two. Right? So if you think about it logically, since Q and P do not match, I take the max between these two, which is going to be 1. There is no match here. Then R and P, they don't match, so I take the max between these two. This is what I have. Now R and P, they don't match, so I take the max between these two and fill this here. Now let's go to row 2. Now what do I have here? Right? What do I have here? Do they both match? Q and Q matches. So what should I do now? I should take this element and add 1 to it. So I have added 1. Now Q and P do not match. So what do? I take the max of both of them. The max of both of them is 1. Now Q and Q match. Look at this. Q and Q match again. Right? Because Q and Q matches, what should I do? Look at this. Q and Q match here. The last one. So what am I computing here? Again, just follow this formula here. So now Q and Q match. To fill this, Q and Q match, which means 1 plus this value, which is 2. Okay, again circle this because we got a match here. Right? Next, what about R? Q and R do not match. So I take the max of both of them. The max of both of them is 2. Again, Q and R do not match. So I take the max of both of them and put it as 2. Okay, if you notice, when there is a match, we are going this way. Okay, just look at my pointer. When there is a match, we are taking this value and adding 1. When there is no match, like this, in this case, I'm taking the max of these two and placing it here. Okay, now let's go to the third row. Okay, P and Q, no match. So take the max of both of them and place it here. Again, P and P, there is a match. There is a match. So when there is a match, what should we do? We should actually take this and add 1 to it. So this becomes 2. Right? Now again, Q and P, no match. So max of these two. R and P, no match. So max of these two. R and P, no match. So max of these two. Right? Very simple, right? Now again, okay, I'll just fill this in. I'll show you some examples here. Let me just fill the whole thing. You can just repeat the whole thing here. Okay, let's take this case. This is actually a very interesting case. Okay, so let me just erase this and show it to you. Okay, look at this. Here I have R, here I have R. R and R are matching. So what should I do? I should take 2 and add 1 to it, which means I get 3 here. So whether I add 1 to this or I take the max of both of them, I get the same value here. That's why this is an interesting case. Right? Very simple. Again, I'll use the same logic here to keep filling. Okay. So here, let's see. Q and Q, they match. Look at this. Q and Q match. So what should I do? I should take this 0 and add 1 to it. Right? Now Q and P do not match. So I take the max of both of them and place it here. Now Q and Q match. Right? Look at this. This is Q and this is Q. Q and Q match. So what should I do? I should take this 2 and add 1 to it. And also circle it. So if I keep repeating this whole thing, if I just repeat this whole thing, look at this. Now look at this. This R and R match. When R and R match, what should I do? I should take this 3 and add 1 to it. Literally what I'm doing in this table is I'm filling these values using this recurrence relation. I'm literally filling this from 0, 0 up to m comma n. Right? I'm literally filling this by just following this recurrence relation step by step manually. Okay, it's important to get a sense of this manually so that you'll remember it. Because when you solve a problem with pen and paper on your own, your appreciation of the problem and what is actually happening underneath improves. And you will also visually remember this table now. Right? So now let's see what happens. R and R matches. So 3 plus 1, 4. So whether I take this 3 plus 1 or I take the max of both of them, it results in the same thing. Okay, so 1, 2, this 2 again, because P and P are matching, it's a match here, right? 3, 4 and 4. Okay, now comes the fun exercise. Now what do we have finally here? We have 4 here, which means the longest common subsequence between strings S1 and S2 has a length of 4, right? It has a length of 4. Okay, so that's the first part. That's the first key observation. Okay, that's the first key observation. The longest common subsequence has a length of 4. But now if I want the exact subsequence itself, how do I obtain it? Okay, we know that the LCS of both of them, the length of LCS is equal to 4. Okay, that is clear here, because what is the final value that I have here? 4. So now if I take the whole string S2 and the whole string S1, the LCS of both of them has a value of 4. Now the next stage. So I got the length. Now I want the actual longest common subsequence, the characters in the longest common subsequence. How do we obtain them? Okay, so let's go step by step. How did this 4 come about? Okay, how did this 4 come about? Let's see this. This 4 came because of max of these two. Okay, so let's pick any one of them. I can pick any one of them. Let's assume I pick this and I draw this arrow. Okay, so I'm basically tracing my path back from here, back to the starting. Okay, how did this 4 come about? Because of max of these two, right? So now, because both of them are 4, let's pick this. I could have picked this also. I'll show that in the next example or just a while later. Now, how did this 4 come about? Okay, this 4 was not because of a matching. If it was because of a matching, I circled it, right? If you notice, I circled it. And I can also verify that it's not because of matching, because P and R don't match. How did this 4 come about? It came about because the max of 3 and 4 is 4. And where is this 4? This 4 is here. So let's actually go up here. Right? The moment I come here, one thing that I observe is this R and R are matching. That's why I circled it. So one of the longest common subsequences will have R as the last character, because this R is matching here. Right? Now, how did this 4 come about? This 4 came about because R and R matched. In the recurrence relation, this 4 came out because R and R matched, and this was generated by adding 1 to 3. Okay, this is a match case, right? So I go from here to here, right? So now when I go from here to here, what do I have? This Q and Q matched here, right? This Q and Q matched here. So this is a circled cell. In a circled cell, I have Q and Q matching. So Q also must be part of my LCS. Okay, now how did this 3 come about? This 3 came about from this 2. This 3 came about from this 2 because this Q and Q matched. Because this Q and Q matched, I took this 2 and added 1 to this. Right? Now how did this 2 come about? This 2 came about because of max between this and this. Right? So, and the max value is here. So I go up now. Now look at the arrows that I'm drawing here. Look at the arrows that I'm drawing here. So I go to this. Now as soon as I go here, it is circled, which means this P and this P have matched. So P also must be part of my longest common subsequence. Right? Now I have this. How did this 2 come about? Because P and P matched here, it should have come from here. This 1 plus 1 became 2. Now when I came here, now this Q and Q are matching and this is circled, which means Q also must be part of my longest common subsequence. How did this 1 come about? It came from here. Okay, so I've reached the end now. I've hit a wall. I can't go any further. So this path, this logical path that we constructed, if I look at all the matches on this path, this is a match of R. This is a match of Q. This is a match of P. This is a match of Q. And this is one of the longest common subsequences that I have. If you notice, this is a common subsequence of length 4, and it is actually a common subsequence between these two. Look at this, Q, P, Q, R, Q, P, Q, R. It's actually a longest common subsequence between these two. But in this case, there is not just one longest common subsequence. There are other common subsequences also. Let me actually show that to you. Okay, let's change the colors here and actually see that. Okay, the other option, because this 4 came, look at this. So for that, we can choose another path. Okay, let's try to choose another path and see what it turns out to be. Okay, so if I go from this 4 is basically a max of these two, right? So I can go here also. right? So I've changed the color from pink to white now. Okay, so the moment I go here, this is a match between R and R. So let's write R, right? Let's write R. Now this 4, how did this 4 come about? Because this R and R matched, it came from this 3 by adding 1 to it, right? Now how did this 3 come about? This 3 came about, okay, let's look at this. This 3 came about as a max of these two. Now I can go here or I can go here. If I go here, I'll merge on the path that I had seen earlier. So let's actually explore the other path. Okay, let's go here. Okay, now here what do I have? I have a match between R and R. Right, here I have a match between R and R. So let's write down R here. Right, I have a match between R and R. And how did I come here? Because there was a match between R and R, it came from 2. I added 1 to 2 to get 3. So now I reached here. How did this 2 come about? This 2 came about as a max of these two. Since both of them have the same value, I can pick any one. So let's pick this different root. See, this is one root that I have. Let's pick a slightly different root to get a slightly different string or longest common subsequence. Now I got 2 here. How did this 2 come about? Because this Q and this Q matched, right? And it came from here. This 1 plus 1 became 2. And the common character here is Q. Now how did this one come about? This one came about because this P and P matched and it came from here. And now I've hit the wall, right? So I also put P. So this is an other longest common subsequence between string S1 and S2. If you notice PQRR, you have PQRR here, you have PQR and R here again. Okay, this is also a longest common subsequence of the same length 4, but this is a other longest common subsequence that I have, right? So if I keep following these paths, okay, these paths might take me on different routes, but they will give me some interesting results. There is one more longest common subsequence that you can figure out in this. If you just follow these paths again the way I followed, you'll also get Q, P, R, R. This is another longest common subsequence that you can find in this example. Okay, the way it works is this. Okay, so here you have 4. Let's go down this path. Okay, from here, so let's actually try to trace it. You go here, you get 1 R. Okay, you get the first R, right? Then you trace this path. Then you go up here again. Then you go up here. You get 1 more R, right? You got 1 more R. Now this 3, right? You got 1 more R, right? From this 3, I go here. Okay, from here, instead of going up, I take a left because this 2 is a max of these two, right? So I can either go up or I can go left. If I go left and again follow this path, I'll get Q and P again. Look at this. Look at the commonality. I get QP from here and I get RR from here because there is a merging of paths here. Okay, so I started here. I went in this path till the time I got RR. But then here I have an option either to go up or to go left. If I went up, I got PQRR. If I went left, I get QPRR. Right? So there are 3 possible longest common subsequences for this example. And all of them are of length 4. Okay? And the best way to understand this is to draw this diagram. This is the table. This is the table in which we store the overlapping subproblems in this. Right? It's a very nice, simple, but a very good example. I strongly recommend that you take this example, do it on your own with a pen and paper on your notebook. Okay, while you have understood all of this, it's very important to do this on your own. You could take these strings or a completely different set of strings so that you get a good perspective on how exactly the longest common subsequence is working in